Good day, learners. I am Mr. Carl Anthony M. Gonzalez, and I will be your math teacher for today's lesson. For today's lesson, we will discuss solving corresponding parts of congruent triangles using SAS congruence postulate. Learners, are you ready to learn? We will start our discussion by unlocking of difficulties. In the previous lesson about SAS congruence postulate, it states that if the two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the two triangles are congruent. And this idea will be useful in today's discussion. Learners, let's recall. Identify the congruent parts and the congruent triangles by SAS congruence postulate and using the special markings. Given the two triangles, what are the congruent parts of these two triangles under SAS congruence postulate? Based on the given figures and to all the markings, we have these two sets of congruent sides. Side AC is congruent to side RQ. Side AB is congruent to side RS. We also have congruent angles. Angle A is congruent to angle R. Since all the congruent parts are already identified, we can now name the two congruent triangles under SAS congruence postulates. Triangle ACAB is congruent to triangle QRS. For our lesson, we need to solve corresponding parts of congruent triangles by SAS congruence postulate. So how do we do this? These are the steps that we need to remember or memorize in solving corresponding parts of congruent triangles by SAS congruence postulate. Step 1. Draw the two congruent triangles with the given measurements. Step 2. Write the congruent corresponding parts of the congruent triangles. Step 3. Rewrite the congruent corresponding parts into equations. Step 4. Substitute the given values in the equations. And step 5. To solve for the unknown parts of the congruent triangles, apply the concept of CPCTC and SAS congruence postulate. Okay, learners, let's discuss example 1. If triangle ABC is congruent to triangle XYZ by SAS congruence postulate, and the length of AB is equal to 15 cm, while the length of BC is equal to 30 cm, and angle B is equal to 60 degrees, find the lengths of XY, YZ, and the degree of angle Y. For the solution of example 1, we need to use the 5 steps in solving corresponding congruent parts of congruent triangles by SAS congruence postulate. For step 1, draw the two congruent triangles with the given measurements. So we have this triangle ABC with the length of AB is equal to 15 cm, the length of BC is equal to 13 cm, and angle B, which is equal to 60 degrees. The next figure is triangle XYZ. We need to determine the length of XY, YZ, and angle Y. For step 2, write the congruent corresponding parts of the congruent triangles. So we have side AB is congruent to side XY, side BC is congruent to YZ, and angle B is congruent to angle Y. For step 3, Rewrite the congruent corresponding parts into equations. AB is equal to XY, BC is equal to YZ, and angle B is equal to angle Y. Step 4. Substitute the given values in equations. AB is equal to 15 cm, BC is equal to 13 cm, and angle B is equal to 60 degrees. For step 5, to solve for the unknown parts of congruent triangles, apply the concept of CPCTC and SAS congruent postulate. Since AB is equal to XY, therefore XY is equal to 15 cm. Since BC is equal to YZ, therefore YZ is equal to 13 cm. And angle B is congruent to angle Y, therefore angle Y is equal to 60 degrees. Let's have example number 2. Suppose triangle SYM is congruent to triangle BOL by SAS congruence postulate. Angle B is equal to 48 degrees. The length of YM is equal to 24 inches. And the length of BO is equal to 19 inches. Find the measurements of the corresponding congruent parts of the given in the two triangles. For the solution of example number 2, step 1, given triangle SYM is congruent to triangle BOL, we have this illustration, triangle SYM with the length of YM is equal to 24 inches, triangle BOL with the length of BO is equal to 19 inches, and angle B is equal to 48 degrees. Now let's have step 2. Step 2, we need to identify all the congruent parts in the congruent triangles. So we have triangle YM is equal to or congruent to triangle BL. Triangle SY is congruent to triangle BO. And angle S is congruent to angle B under SAS congruence postulate. For step number 3, we need to equate all the congruent parts into equations. So we have YM is equal to BL, SY is equal to BO, and angle S is equal to angle B. For step number 4, we need to substitute all the given in step number 3. YM is equal to 24 inches, BO is equal to 19 inches, and angle B is equal to 48 degrees. For step 5, we need to use step 3 and step 4 to determine the unknown length of the two sides and the included angle. So we have BL, which is equal to YM, and YM is equal to 24 inches. Therefore, BL is equal to 24 inches. Same thing for SY. SY is equal to YM, and YM is equal to 24 inches. Therefore, SY is equal to 19 inches. Then lastly, we have angle S, which is equal to angle B, and angle B is equal to 48 degrees. Therefore, angle S is equal to 48 degrees. So now we're done in example number 2. Let's have the last example, example number 3. Solve for the unknown measurements of the two congruent triangles below by using CPCTC and SAS congruent postulate. For this problem, we need to solve the following: values of x, y, and z, the lengths of EU, UM, NU, and UL, and the angles EUS and LUM. For the solution of example number 3, step 1, write the corresponding congruent parts of the two triangles by using SAS congruence postulate and the markings in the given figure. We have EU is equal to UM, NU is equal to UL, and angle EUN is equal to angle MUL. Step 2. Substitute the given values and solve for the values of unknown variables. To solve for y, we need to use side EU and side UM. Based on the figure, EU is congruent or equal to UM. EU is equal to 7y minus 8 and UM is equal to 3y plus 20. Since EU is equal to UM, therefore 7y minus 8 is equal to 3y plus 20. Then, combining similar terms, so we will have 7y minus 3y is equal to 20 plus 8, and simplifying both sides of the equation, we will have 4y is equal to 28. And dividing both sides by 4 by using the numerical coefficients of y, we will have y is equal to 7. To compute for the value of x, we need to use NU and UL. And based on the figure, NU is equal or congruent to UL. NU is equal to 5x plus 2, while UL is equal to 3x plus 24. Since NU is equal to UL, then we have 5x plus 2 is equal to 3x plus 24. Combining similar terms, we will have 5x minus 3x is equal to 24 minus 2. Simplifying both sides of the equations, we will have 2x is equal to 22, and dividing both sides by the numerical coefficients of x, we will have the value of x which is equal to 11. To compute for the last unknown variable, which is z, we need to use angle EUS and angle LUM. Based on the figure, angle EUS is equal to angle LUM, or they are congruent to each other. Angle EUS is equal to 3z plus 45 degrees, while angle LUM is equal to z plus 49 degrees. Since angle EUS is equal to angle LUM, we can say that 3z plus 45 degrees is equal to z plus 49 degrees. Combining similar terms, we have 3z minus z is equal to 49 minus 45. Simplifying both sides of the equations, we have 2z is equal to 4. And dividing both sides to eliminate the numerical coefficient of z by 2, so the value of z now is equal to 2 or 2 degrees. For step number 3, substitute the computed values of x, y, and z to determine the measurements for sides EU, UM, NU, and UL. Also, we need to compute for angles EUS and angle LUM. EU is equal to 7y minus 8 based on the figure, and the computed value for y is 7. Substituting the value of y to the values of EU, or to the y in 7y minus 8, so we will have 7 times 7 minus 8, then 7 times 7 is 49, minus 8, and simplifying that, we will have the value for EU, which is equal to 41. EU is congruent to UM, and UM is equal to 3y plus 20. Since the computed value of y is 7, substitute this to UM to all y's in the given equation. So, we will have 3 times 7 plus 20. 3 times 7 is 21. Adding 20, so we will have the value for UM, which is equal to 41. For NU, which is equal to 5x plus 20, we need to use the computed value for x, which is equal to 11. Substituting this value to NU, we will have 5 times 11 plus 2. 5 times 11 is equal to 55 plus 2. And simplifying 55 plus 2, we will have the value for NU, which is equal to 57. Then for UL, we have 3x plus 24. The value of x is 11. Substitute that to replace all the values or value of x in 3x plus 24. So we will have 3 times 11 plus 24. 3 times 11 is 33 plus 24. Adding these two numbers, we will have the value for UL, which is equal to 57. Let's now compute for the remaining parts. Angle EUS, which is equal to 3z plus 45 degrees based on the figure. The computed value of z is 2 degrees. Substitute this value, so we will have 3 times 2 degrees plus 45 degrees. 3 times 2 degrees is 6 degrees plus 45 degrees. Simplifying these two numbers, we will have the value for angle EUS is equal to 51 degrees. And the last part, which is angle LUM, which is congruent to angle EUS, we have this expression equal to that angle, z plus 49 degrees. We also use the same value for z, which is 2 degrees. So we will have 2 degrees plus 49 degrees. And simplifying these numbers, we will have the values for our value for LUM, which is equal to 51 degrees. Since we already compute for the unknown variables and for the unknown lengths of these two congruent triangles, we're done in example number 3. Okay, learners, keep in mind, if two triangles are congruent, then their corresponding parts are congruent. The SAS congruence postulate, or side angle side, if the two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles are congruent. These ideas can be useful in solving problems or in solving corresponding parts of congruent triangles by SAS congruence postulate. Again, this is teacher Carl Anthony Gonzalez. Thanks for watching my video. And please study hard and God bless you. Goodbye.